Welcome, everyone. Oscar Wilde wrote that experience is the name we give to our mistakes. We learn from mistakes. When we design a solution, in the very beginning, it seems that it satisfies our needs. But as the system grows bigger and bigger, problems arise. And eventually, we find out that the solution could have been wrong. The thing is, we couldn't see it in a small scale. A small problem becomes a very big problem in a big system. And that's exactly what happens with primitive obsession. That's a situation where we overuse primitive types all over the place instead of providing more specific and more meaningful types. In this talk, we will see simple TypeScript techniques that help us to provide a better design for data models within frontend and backend applications. My name is Tomasz, and I'm a software consultant and architect. I help teams to scale their work. I also do trainings on topics such as JavaScript, TypeScript, architecture, various tools and frameworks, and so on. So let's start. Imagine we work in an e-commerce application, and we are selling some products. There is some price, there is some product quantity, etc. And we carry on with numbers. And we have a variable product count 12 and unit price 1.99. Let's say it's PLN, Polish zloty, dollars, whatever. The thing is, when we start, let's say, changing the values, we assign 13, then it's actually okay because it was 12, now it's 13, so it's okay. But if we want to assign a unit price to a product count, it doesn't make sense, right? Because that's a price, and the count, the quantity, the number of items, that should be an integer. But come on, that's just a number, right? And a number is a primitive type that is being processed by the system, by the processor, and we can add things, we can subtract, multiply, divide, square root, calculate sinus, cosinus, and all this stuff. Is it possible, for instance, to square a price? Is it possible to square a count? These operations basically don't make sense. But we work in an area of all numbers that is basically quite primitive, that is very, very low level. So that's the thing where we need to provide better types. It means we need to provide better shapes. If something is, as let's say, compatible with other things, just like the square in the video over here, then it's simply not going to be very helpful. The same, if we have a discount that is 0.99, subtracting the discount from the product count basically doesn't make any sense, right? So what if we try to provide a solution that there will be a specific type for money? Or unit price multiplied by unit price. No sense, but still possible, not only in JavaScript, but also in TypeScript. That's just a number, right? Or product count, that would be multiplication of unit price by discount. Again, doesn't make any sense, though the compiler would allow it. The thing is, you could say, well, if I fall into a bug like this, a problem, you could say that, well, just fix the line, right? But the problem is, if I get a runtime error, and I fix it, it's still possible that similar runtime errors would appear if a new person joins the team and basically make the same mistakes, right? When we have a runtime error, it would be nice if we could disable the whole problem at all on a compile time level. What if TypeScript could disallow us to fall into such a situation, right? Runtime errors would not happen. So, all in all, what we want to achieve is to fix the cause and not the symptom. We don't want just to fix the line. Of course, we need to fix the line that causes an error, but we want to make it impossible to make such a mistake. So what we're going to see in a while is that type safety in TypeScript is actually kind of configurable so that we can change the shapes, like we've seen this, squares, rectangles, and wheels, etc. So we can change the shapes so that structural typing in TypeScript could reduce the compatibility between various types. We're not forced to use just primitive numbers. So the first step that we can do is to provide an alias for a type. So we create just type money equals number, and we create a unit price variable that is of type money, that is 1.99. So not very much changes, right? we just provide an alias. For TypeScript, it's still going to be a number, but in each function, each class, each object, each method, whatever we use, we're going to use the money type from this moment. What this changes is we provide better intent, what I meant within the code, so that when somebody will be reading it, it will be okay, it's just not a number. It's meant to be money, it's meant to be a price. So it's not just any number, but it has some more meaning. Other people would know what I wanted to do with this, what is the responsibility, right? So we're just using the money type within our functions. Of course, when we pass unit price into this function, it's going to pass. When we provide just a number, it will still pass. So from type safety, type compatibility perspective, it doesn't change much. But the benefits that we get is that there is better, it's more readable. We can figure out what was the intent of the author of the code better. And if we wanted to provide something more, let's say, robust, more extensible, etc., there is just one place to change what is actually the money in our system. Now, it could happen that for many years you could be going on like actually okay with using number for a money type. But let's say if the product owner or any kind of person from business comes and they say that we need to implement currencies. If you're using number all over the place and you work in a, let's say, big e-commerce system, that could be a few hundreds of places to change, or a few thousand maybe, right? So how to estimate that? That would be pretty difficult. So the thing is, we pay very small price to provide the alias, and there is just one place to change if we want to extend that type. So we don't get type safety yet, but we get single, let's say, type level, single source of truth, and a better intent and readability of the code. What we can do as the next step is to provide what is called a brand type or an opaque type. That's just two names for the same thing. So we provide a symbol. Now, we don't really need to understand what specifically symbols are. The thing is, we are going to extend the base type that we provide. By extending, we are creating a more specific subtype, so we are changing the shape of the structure, right? TypeScript is structurally type, which means that it doesn't care whether you implement an interface, whether you extend a class, or whether you are of some given type. It just doesn't care at all. It cares whether your shape is what is expected. So how can we configure type safety? By changing the shape. So what we're doing is we are adding one artificial property. It's not going to exist in runtime. It's purely a compile time property. So in some way, we are cheating the compiler. But the thing is, the shape would be different. So examples of brand types is, let's say, money, which is a special number type, which will be dealing with money, or a special string type that will be a correctly formatted date string, or an email string that would be a correctly formatted string. Now, when we create a my address variable, and we want it to be an email string. Now, this could be a valid email, but we have no guarantee, right? So unless we check whether this is okay, TypeScript would not allow us to do it. Email string is a subtype of a string. The same way as we have supertypes and subtypes of object, the same way we have supertypes and subtypes of primitives. So unless we check that this really is an email string, we don't know it, so TypeScript is not sure. It cannot guarantee it, right? So it will not allow us to assign it. So all in all, each email string is a string, but not all strings are email strings, right? So we cannot just assign something more general to something more specific because that's not type safe, not only in TypeScript, but in all statically typed languages. So what we can do is to tell TypeScript that please treat this thing as an email. So we are just doing a type assertion to downcast it to an email string. And from now on, this would work. But what we can actually do further is to introduce a validation. And we're going to provide a function that will actually do it. So let's say that we have a send email function that accepts something that is an email string. So if I want to actually send the email, I need to make sure that the string that I pass is not just a string, but is a valid email. So we create, again, a myAddress variable that would hold a string. We don't yet know whether this is a string or not. So when we want to pass it into the send email function, it will not compile because, well, we're not sure whether a string is actually an email string. So what we do, we're just creating a function, and it could do any kind of validation. Email is here just a simple example. But the thing is, we're creating a type guard in TypeScript that will basically do a runtime validation whether all the rules related to this specific type, whether they pass or not. That's just a type guard function. And when we go through this function, inside the if statement, my address is an email. That's just a type guard, but we're using it to make it more specific. Imagine all the rules that you can make sure that there is no possibility from now on that you would pass something that is not a valid email. Of course, email is, again, just an example. You could put any kind of validation logic or any kind of logic that would check for your business rules within this. So, one step further that we can go, the limitation here is that still it's a primitive. In runtime, we're not going to have this artificial property. But we can still, let's say, execute all the properties, all the operations that we could run on numbers or on strings. But what if we wanted to introduce some more rules to be checked for within our code? Let's say that we've had our money, we've had our amounts, and we need to implement some more currencies. And we have an object sum which includes 1999 Polish zlotys and $50. And as you see where I'm going to, we want to add the money. But the thing is, we cannot just add money from different currencies, so there needs to be a logic that would check whether this is possible, right? We need to make an if statement. And now the question is, where would we put that if statement? If we work in frontend, that might be put into in a component or a hook or whatever you're using, or an Angular service, or if you're working in some backend MVC, that could be a controller, whatever. But wherever you would like to do this addition, you would need to check whether all the rules exist, like they don't have their place, right? So you could keep on copying this stuff, and if it changes again, multiple places would have to be changed. So what we can make use of, just to introduce a place for where should this if statement and many more if statements live, would be to introduce what is called in domain-driven design a value object. So in very short, instead of creating a primitive, we want to create an object. You could think of it as an over-engineering. Well, sometimes it could be, but if we have this logic, like checking the rules, it has to live somewhere, right? So what is our alternative? That we would have copy-pasted if statements here and there, like tens of copied if statements, or maybe we could just replace it with an object. So what we have here is just a constructor. Well, it could be public, but if we want to allow a possibility where we would put some more logic here, we can provide a static method to create an object. That's just some kind of boilerplate. If we want to access the value, for instance, the amount, here we can provide some more methods. That's just boilerplate. But the whole idea behind value objects is to create meaningful methods. For instance, what can we do with a number? As we've said, we can square it, we can make a square root, we can make a sinus, cosinus, multiply, divide. Can we multiply $10 by $10? It doesn't make sense, but if we keep on using numbers, well, that would be possible. So we walk into impossible state and basically kind of illogical state. So we're listing all the possible operations that we can do here. So what we can do is actually add money to another money, or we can multiply money, but not by another money, but a factor that is a number. This makes sense. And we just list all the operations that are possible. Just to make it impossible to fall into problems, to make bugs. So, for instance, where should this if live? Basically, within the space of money. That's basically the space of money. So any kind of business rules that we need to check, that's the place for them to live. Or the multiply. We're just going to multiply the amount by the factor, but there is no possibility to make, again, such a problem outside of this class, right? So we make it impossible to reintroduce the bugs. So which way to go, just to summarize the whole thing? We start with primitives everywhere, and our first step could be to introduce a type alias. This is a very cheap solution. We're just introducing alias. What we benefit from here is we get one place that we need to update so that a meaningful type updates throughout the whole system. That's not very invasive, but it's very flexible in the future. And I don't mean that we should provide type aliases for everything. Well, when we start with a, let's say, financial system, we can start with type money, which is a number. And could the money type change? Well, sure. For instance, it could have currency introduced, as we've seen. But if we have, let's say, users, could a user name change? Could it be something else than a string? I don't think so. So let's not exaggerate the stuff. Let's not provide type aliases for everything. But if you think that within your domain something could be extended in the future, just provide the alias and use it. Now, if you do already have an alias and you would like to limit the compatibility across, let's say, money and just quantities or across different types of number, then we can introduce a brand or opaque type. Now, again, we don't need to understand what the symbols do. Basically, we are just creating a, we can say, a private property that would not exist on other types, and hence they're incompatible. So we're making sure that different types of numbers are not compatible across each other. But still, all operations on number are possible. Now, if you consider that it does make sense to go even further, because within your, let's say, money space, you do have some operations that you want to make safe. For instance, as this add, that you want to have a place to put your business logic in. A value object would be a very good solution, and actually lots of backend applications either implement or should do this. So one thing I would like you to remember is that fixing the line that is causing the bug is not yet the whole success, it's just the half of the success. Our success would be to make it impossible to reintroduce this bug again. There is one more thing I would like to say, that I'm very grateful that I can stand in front of you, in front of the lovely audience and speak about code. And there are some people who should be here, but they cannot because they have to fight for their lives and their freedom. And I would like to send a message to all Ukrainian sisters and brothers. We stand with you now, and we'll stand with you in the future. That's all from me. Thank you.